Hi everyone, this is Dr. Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering typology subject. In that part, the mechanism of various types of wear topic is there. So today we will discuss about the mechanism of various types of wear. So already in the previous session we have discussed about wear and then the types of wear and how to reduce this the wear phenomena we have discussed. So in this today's topic session, we will see the mechanisms, various mechanisms are there in the part of the wear. So if tribology subject involves the friction, wear, and lubrication, already you know these three parameters are very very important. So the friction already we have studied. The second one is wear we are discussing. So the wear is defined as the undesirable thing. So but inevitable removal of material from the rubbing surfaces. So though the removal of material from the surface is very small, it leads to reduction in operating efficiency. So it means so whenever the two rubbing surfaces are there, so contact two surfaces are contact each other, there is a friction and then there is a wear. So actually it is a undesirable, not desirable. This wear is not required. But whenever you are operating machining, somewhat material you have to remove. So this leads to affect the machine efficiency and entire leads to cost of labor also. So classification of wear mechanism classified into various types, mainly three. One is wear by hard particle or liquids. The second one wear by sliding and rolling contact. Third one is chemically assisted wear. So the wear is mainly classified into three. So whenever hard particles are present on the surfaces, there is a wear due to the scoring of the material. And similarly by liquids. And then whenever two surfaces are sliding or rolling contact, there is a wear between two surfaces due to the various of the factors. It's based on the material properties, based on the type of the lubricant, based on the atomic structure of the material, based on the environmental conditions. All these things influence the wear. So third one is chemically assisted wear. The chemically assistance. So whenever two materials are in contacts are two materials in a relative motion. So contact of surfaces, there is a chemical reaction between these two surfaces. Due to this chemical reaction, what will happen leads to wear. The first one we will say where hard particles are liquids. So this is well-known wear process comes under this category include abrasion, adhesion, corrosion, solid and liquid droplet erosion, and cavitation erosion. So the wear process fall into this category. So collectively, these account for nearly 80% of all wear related cost in industry. So already we have discussed about survey in industry. So they have given one report abrasion percentage 80%, adhesive 50%, chemical wear is 8%. So like that, they have given data based on the survey. So similarly, all these things, nearly 80% of all wear related cost in industry. Next, abrasive wear. So this is the form of wear which occurs when a rough hard surface or a soft surface containing hard particles slides on a softer surface and fall a series of grooves in it. So it is the this is one type of wear when a two surfaces are in contact. So one is harder surface, another one is soft surface. So these two surfaces are containing hard particles. When it slides on a softer material, then there is a wear. This type of wear is called as abrasive wear. The material from the grooves is displaced in the form of wear particles, generally loose ones. The, this figure shows the schematic view of to body abrasive wear mechanism. So wear can also takes place whenever hard foreign particles such as metal grit, metallic oxide, and dust and grit from the environment are present between the metal and then tear of the metallic particles. So the former type is called as two body abrasion and the latter three body abrasion. The shown in figure A and B, the figure 1 A is called as two body abrasive wear. So abrasive wear whenever hard foreign particle such as metal grit and metallic oxide are present between the metal and the other surface. So that is metal surface and the matrix, the metal grit and metallic oxides. Another type is three body abrasive wear. Schematic way of three body abrasive wear mechanism. In this, additionally added the dust and grit from the environment. So the abrasive wear takes place between these three bodies. Surface A, surface B, and another third one is third foreign material is grit. So depending on the severity, abrasive wear is classified into going, grinding, and scratching abrasion. So this again this abrasive wear classified into these three types that based on the severity. So abrasive wear is one of the most common types of wear encountered in engineering practice, and it is probably the highest single cause of wear in many machine applications. It is one type of wear very common in engineering practice, engineering elements. So in this diagram shown, the schematic view of abrasive wear mechanism. So the cutting of force on a surface by hard particles, for example, sand particles between contact surfaces, or hard asperities on an opposing surface. The cutting of force on a surface by hard particles. Due to the hard particles, the cutting will be possible. Sand particles between contact surfaces, one example. Another one is whenever present hard particles, hard foreign material particles on an opposing surface. So two body abrasion shown and a three body abrasion. In this, one is soft, another one is hard. In this also same hard surface and soft surface. So due to in this between, the third body will be present. So after examination, you can find embedded particles and scratch marks. This is this is the mechanism of abrasive wear. So whenever hard particles present between contact surfaces, there is a abrasive wear possible. So how to prevent this abrasive wear? So one is mechanical related, another one is lubricant. What we have to do mechanically? Remove abrasive by improved air and oil filtering. One is improved air and oil filtering, clean oil handling practices, improved seals, flushing, and frequent oil changes. So, to avoid this type of wear, that is abrasive wear, first remove the caused particles. Suppose in hard particles are present in between the two surfaces. So, with the help of air, you can improve, remove, and then with the help of oil filtering, you can remove the particles. So frequently, you have to change oil, lubrication oil. So somewhat you can minimize the abrasive wear. So which type of lubricants have to use? Use oil free of abrasive particles. This is the one type of prevention. The second one is, so same one. The second one is minimize short peening, beading, or sandblasting of surfaces because abrasives cannot be completely removed. So already I told you. So whatever scratches are there, you can't eliminate permanently, but you can minimize. Salt pinning, beading, sand blasting, you can minimize. For this, use more viscous oil. The lubricant, the prevention method is use more viscous oil. Next one is adhesive wear. In this diagram, shown the view of adhesive wear mechanism. We shown this in this plastic zone, adhesive transfer possible, the wear fragment. This is one type of wear which occurs when two smooth bodies are slide over each other and the fragments are pulled off one surface to adhere to the other. So whenever two smooth bodies are slide over each other, some the fragments elements are pulled off one surface to adhere to the other surface. So due to this phenomena, adhesive wear will be occurred. So you can see in this diagram, shown detailed diagram here, plastic zone. So adhesive transfer possible wear fragment. So later, these fragments may come off the surface on which they are formed and be transferred back to the original surface, or else form a loose wear particles. So depending on the severity of this action, this adhesive wear further classified as galling, scupping, scoring, and seizing wear. So it is caused by a shearing action of micro welds formed between the surface asperities that actually carry the load between two mating surfaces. So whenever these fragments transferred formed to be transferred back to the surface, original surface, then some wear particles will be formed and then lose some particles also. So due to this shearing action, the micro wells formed between these two surfaces. So for this wear, so mechanically you can reduce load, speed and temperature. You can minimize the adhesive wear. Don't apply extreme load. Don't apply extreme speed. Similarly, temperature. Improve oil cooling. Use proper lubricants. Use compatible metals. Don't use other metals. The properties of the two surface metals should be match. Otherwise, there is a reaction between chemical reaction between the two surfaces will be possible. Increase hardness of metal surface to prevent this adhesive wear. So lower hardness of metal gives more wear. For this, use more viscous oil to separate surfaces. Without more pressure, smoothly smooth surface separation of surfaces will be possible by using viscous oils. So that's why you should concentrate on metal properties, mechanical properties and chemical properties and electrical properties. Many properties are there. So based on these parameters, based on the mechanical properties or chemical properties, the wear influence. So that's why use always compatible metals. Next one is corrosive wear. This type of wear occurs when sliding takes place in a corrosive environment. So whenever two surfaces are in a sliding action, so that sliding takes place in a corrosive environment, then wear occurs. This type of wear is called as corrosive wear. So in the absence of sliding, the products of the corrosion would form a film on the surfaces, which would tend to slow down or even arrest the corrosion. But the sliding action wears the film away so that the corrosive attack can continue. So I will show you the figure. It is not easy to find a good illustration of corrosive wear, but an example of it is the IC engine, internal combustion engine cylinder surface wear. The inside cylinder, the piston moves top dead center to bottom dead center. So but the sliding action wears the film away. The corrosion. So if not used proper lubricants, corrosion attack can continue. This is the corrosive wear. This is the schematic view of oxidative wear mechanism. Oxide zone and fresh oxide. In analyzing a wear problem in a machine, it is necessary to determine the kind of wear that occurred. So, which type of wear occurred? First, you have to identify. Then only you can analyze the wear problem. Otherwise, you can't calculate the wear. First, understand the kind of wear. Analysis requires microscopic examination of the worn area and a close look at the used lubricant. So, which type of lubricant is used? You have to look. And under examination, the microscopic examination, you can see the worn area. So, wear is generally proportional to the applied load and the amount of sliding. The wear is generally proportional to the applied load and the amount of sliding. The applied load is increased, the amount of slide also will increase automatically. wear also will increase. It decreases the load, the sliding and wear also decreases. So that's why the wear is always proportional to the applied load and the amount of sliding. The corrosive wear prevention, how to prevent. Mechanical related use more corrosion resistant metal, not stainless. Other materials use. Those materials can withstand the corrosion. Similarly, reducing operating temperature. And lubricant is remove corrosive material such as two chemically active, additive and contaminants. For this, remove corrosion material such as two chemically active and then apply lubricant. The second one, use improved corrosion inhibitor. Reduce the operating temperature. For this, you should improve the corrosion inhibitor. Then only you can minimize the corrosive wear. So one is use the resistant material, and another possibility is operating temperature. Reduce the operating temperature. The third one is eliminate the corrosive material. So whatever the material, the caused material is there, so eliminate that material. Don't use the corrosive material. So use fresh oil or lubricant. So these type of prevention is possible for this corrosion wear. So actually, this corrosive wear happens when the two metal contact surfaces are in relative motion. There is a chemical reaction between these two surfaces. So that is one possibility. Another one is the operating conditions. So that is environmental condition. So based on the environmental conditions, the corrosion forms on a surface. So you can remove the corrosion. So that's why instead of removal, don't use corrosive material. The material also should withstand the corrosion. That's resistant metal. Okay, remaining mechanisms are there: erosion and electro corrosion mechanism and fretting mechanism. So next session we will discuss. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.